Welcome to Dunwoody College of Technology. This is Statics Fall 2019 Quiz 7 solution. So in this problem we're given a distributed load on this beam. We have this function here that's describing the distributed load. We're told what it is at the end and what it is at the beginning here. And we're asked to replace the distributed load with an equivalent resultant force and the location from point A at which it should act to have the equivalent result on the system. So looking at this, we don't really need a free body diagram since we can draw right on this. If we were working from the book, we might draw a free body diagram of this. Intuitively, where would this resultant force act? Well, it would act a little bit farther over to the right than to the left. How much so? It depends on that function. So looking at the ways that we earn points, we get 2 points for the setup of the resultant force, 2 points for finding its value. We're going to take the moments around point A, the value for that, and that could be an intermediate step, that's fine, and then the location for our resultant force, x bar, will give us our full 10 points for this problem. So what are our steps? Step 1, we're going to calculate FR. And if you recall, that's the integration from 1 to 2 of w of x dx. Second, we're going to calculate MA, and that's the integration from 1 to 2 of w of x times x dx. And then 3, x bar is going to be that moment over our resultant force. That will get us our distance in feet in this case from A to that location. So let's start. So we have our resultant force, our distributed load here is this x squared plus 3x plus 100. So FR, we have x squared plus 3x plus 100. Integrate with respect to x, and our limits of integration are going to be from 0, where this is 100. So when x is 0, we get 100, so that's right here where this w is, to 15. So that integration, we get x cubed, bring down that integer, the exponent power down, so x cubed over 3 plus 3x squared over 2 plus 100x from 0 to 15. And when we fill in those values, we find that this is 2,962.5 pounds, or call it 2.96 kip. Alright, so there's that first bit. That should get us 4 points. The second bit, the moments around A, again, integration from 0 to 15. Now we just multiply this term here by x, so we get x cubed plus 3x squared plus 100x. We integrate with respect to x. So when we do that, we get x to the 4th divided by 4 plus 3x cubed divided by 3 plus 100x squared divided by 2 from 0 to 15. So when we fill in our values here, we can see that our 3's are going to cancel. So we just get x to the 4th over 4 plus x cubed plus 100. We can simplify that out. Then we're going to get 50 x squared. So when we do that, we get MA equals 27,281.25 pound-feet. And then last, we're going to do x bar. Is MA over FR. So we get 27,281.25 over 2962.5 pounds. This is pound-feet. So our pounds will cancel out. We'll just end up with feet. That's what we want. Plugging that in our calculator, we get 9.2089 feet. So in summary, FR is 2.96 kip, that's our three significant figures. MA is 27.3 kip feet, and X bar is 9.21 feet. And just as we suspected, oh, I drew off the edge there, sorry. Just as we suspected that X bar being 9.21 is farther to the right than to the left, so that matches our intuition at the beginning, and we could just replace this whole distributed load here with this force of 2.96 kip at 9.21 feet.